Hello and welcome to this week's What Were They Thinking? The news this week covers a range of things. It starts with the Astrazeneca vaccine and how there's continued controversy about it, but at least from the scientific point of view, there's a general consensus. Researchers have found ways to develop embryo-like forms that could be used in research, but require no controversial sources of material. And also why we are seeing more twins than ever in the current world. Let's start with the Astrazeneca vaccine. In recent weeks, there's been a growing concern among a number of countries that it is causing blood clots, particular kinds of blood clots. As a consequence, a number of countries have put a hold to its utilization and distribution. This particular adverse reaction, if it is that, is characterized by a sort of widespread blood clot, but it's also accompanied by a low platelet count and internal bleeding. These are not normally things that go together, especially not when thinking about a stroke or a blood clot. Normally you get one or the other, clotting or bleeding, rarely both together in this way. There are certain pathologies where it can happen, but this pathology wouldn't be caused by the vaccine itself, and so we're left wondering why we're seeing the phenomena after vaccines have been administered. This does require some further clarification though. The AstraZeneca vaccine is available in the UK, where it's primarily being made, or at least originally was, and is perhaps best described as the first choice. It's also available in America, where there have been limited cases of clotting occurring. What's being seen in both America and the UK is an almost non-existent incidence of this particular adverse event. To be clear about it, the UK has so far not reported any similar clusters of blood clotting disorders. This is despite having vaccinated 10 million people. In other countries, they're seeing things in the low double digits, less than 20 in most cases, and sometimes barely out of the teens. That's a very small number of people having an adverse event like this, and that raises all sorts of concerns about the concern itself. At the moment, at least as far as reasoning for why this is occurring, it's really theoretical, and the front-running theory is that it's actually an extremely strong immunological reaction that's causing it. The body has a variety of systems in place as far as the immune system is concerned that deal with infection different ways. Some of them are always active but at a low level. Others are targeted, and we use these when it comes to vaccinations. The fact that both arms of the immune system get activated simultaneously when we vaccinate someone can at times lead to the body having something of an overreaction. And that's the theory here, that the body's having an extremely strong immunological reaction to these vaccinations. The big part of the immune system that's thought to be at fault for this, if it is happening, is the complement system. Complement has a known area of pathology called complementopathies. One of the things that is fairly common to these is thrombocytopenia or clotting problems. And this is more or less what we're seeing with these clotting disorders following vaccination. At least regarding vaccinations, it was known early on that there might be allergic reactions, and this is one reason why those who are prone to anaphylaxis have been advised not to have the vaccine. If it is essential to do so, then you are advised to have it done in a hospital, where they can deal with the anaphylaxis effectively and quickly. While we are still on the topic of the AstraZeneca vaccine, more news has come out on it, and that is, in short, that the European Medicines Agency has said that it could not find fault with the vaccine. In particular, it could not connect any kind of blood disorder to the vaccine. And this plays into what we've already mentioned, that there seems to be a very low incidence. To be more specific about it, it appears that there are 7 instances that are linked to the vaccine in a way that could be understood and rationally thought out based on the evidence. That's 7 cases in America, and there are 5 million people who have been vaccinated. That is less than a fraction of 1%, and we're getting into ridiculously tiny numbers. These tiny numbers are not just tiny, but equal to or less than what you see in the general population. That would indicate that all we're really seeing here is something of a bias in sample selection. That is, we're being more mindful of adverse reactions and attributing an otherwise unrelated event to being an adverse reaction. This is largely in line with what the EMA is saying, that looking at what's happening, they can't seem to find a way to correlate the small number of cases of an otherwise rare and unusual event with the vaccine. This is further supported by their own investigation of clinical data, autopsies, and so on. 191 cases were found in Europe, or at least the Europe Economic Area, and this was 191 cases among 20 million people who have been vaccinated. Math may not be our strong suit, but that's a 0.000000955% incidence. The average across most people is an average prevalence of about 0.000015%. You can see that there's a substantial difference in the prevalence amongst those who have received the vaccine and those that haven't. This, of course, largely sidesteps the issue of whether or not the vaccine does more good than harm given how prevalent the CCP virus has become. With that in mind, and thinking of prevalence particularly in America, there is concerns based on studies that the current reporting of its spread could be drastically underestimating just how widespread it is. In fact, it could be half of what's happening. That owes to the large number of asymptomatic people, possibly as much as 40% according to this study. That means that 40%, nearly half, of people who have the virus aren't going to be tested, aren't going to be added to official figures, and aren't going to be counted, ultimately leading to that significant underreporting that we've mentioned. The way this study was run means that the results, although at this stage somewhat tenuous, should be considered more thoughtfully than other studies have been. They had nearly 62,000 participants for their study. Of these, more than 4,000 had antibodies for the CCP virus. That's about 6 to 7 people in every 100. When you start looking at these numbers on a much larger scale, you see how things begin to blow up very quickly. When you scale the study to match the US population, you find that that is twice the incidence that should have been found if the current counts were accurate and reliable. This is a concern for several reasons. The primary driver is that asymptomatic carriers can still infect others. This means that even if they aren't necessarily sick in terms of having symptoms, they are still sick enough to make others unwell, which continues to spread the virus around and keep it in circulation. This is a good reason why cheaper but less accurate, but more easily used, antigen test kits should be used more frequently. A cheap, quick, and easy test that can be conducted by anyone on a regular basis would be useful in catching more of these people who are otherwise asymptomatic and would provide better or at least more accurate data that would allow us to figure out just how widespread the CCP virus really is. While on the topic of research that could be considered divisive, or methods that are divisive, there's another controversial study coming out. This study has allowed researchers to take skin cells and effectively backwards engineer a very early stage human embryo. This removes many of the issues that are raised from either moral or ethical arguments. These largely being that the only way prior to this study to get these sorts of samples to develop embryos from ovum that have been donated to research. Generally speaking, these are considered controversial for a number of reasons amongst many groups. This method would mitigate the problem of the moral or ethical argument involved in just how they are developed and how they're used. As the human embryo begins developing, it goes from 2 individual cells to 1 cell that has all the DNA required to produce life. This then undergoes a process of cellular reproduction that creates more cells. These cells eventually form a blastocyst. This blastocyst is one of the earliest points of life in a manner of speaking. It has dedicated cells, functionality, metabolism, and more. Understanding what happens at this point in the development of an embryo could have huge ramifications for long-term developmental disorders. The advantage to this over the other methods we have mentioned is that the skin cells, the way they've been modified, don't allow the human blastocyst to continue developing into an embryo. That has its advantages in terms of removing that moral or ethical argument. It also means that researchers can begin looking at what effects toxins might have on developing embryos and ways to try and either prevent or reduce the risk of miscarriage. While still on the topic of reproduction, there has been a study looking at why twins are being born more frequently than they have been historically. About 12 in every 1,000 births is a twin birth at the moment. That is a very high number, and it's unusual. Twins are not exactly a normal phenomena. The prevalence of twins increases with age, IVF, and a few other factors, but overall, it's not something that should be common or increasing in how common it is. Despite that, it's about 30% higher than it has been from the 80s. While that 30% rise is amongst some of the highest across the world, there have been almost no countries or regions that have had a decrease in twins over that same period, and most have seen at least a 10% increase. Some as high as 71%, particularly notable in America and Canada. While the next piece of news isn't necessarily reproduction related, it could be. It involves the bacteria responsible for urinary tract infections. As you can imagine, the urinary tract is not exactly the most nutritious of environments. Bacteria have to begin destroying cells around them and modifying their environment in order to get what they need as far as nutrition goes. One thing they do have ready access to on a reasonably frequent basis is urine. One particular Streptococcus species is able to take urine and convert it into its own DNA building blocks. This is not only surprising, but kind of ingenious. Urine is acidic and generally quite toxic to anything. As a result, it's quite an effective means of removing infectious agents, such as bacteria. They either get washed away physically or killed chemically. One advantage that the bacteria have from the urine is that the urine has a lot of nitrogen in it, and nitrogen-based compounds are necessary to build DNA. Using the urine that is otherwise intended to remove the bacteria and instead using it to create the DNA needed to then replicate and create more bacteria is, as said, somewhat ingenious. Targeting this particular phenomena in bacteria behind urinary tract infections could contribute to new ways to handle them, a particularly noteworthy idea given that many urinary tract infections are becoming harder and harder to treat with antibiotics. While not quite in line with infections and bacteria, there is another piece of research that involves growing things, and in this case, growing an entire gland in a petri dish, a tear gland. Researchers then made the tear gland cry. This is probably why scientists have a bad public image at times, making their research things that they've created cry. This again relies on the use of stem cells and inducing them to change in the right ways, and then having the right signal to produce a tear. The researchers were able to use genetic modification to change the two kinds of glands found in the tear ducts. Working together, these two are what create the necessary components of tears. By modifying them this way, they're able to create not just a model of the tear duct, but a model of the tear duct that hasn't really existed before now. This would allow research into various treatments for things that would affect the eye's ability to create tears. This in turn would either affect moisture or not having enough moisture in the eye, which is its primary function. The final news we have for you this week regards nothing so much modern as ancient. The Antikythera mechanism. You may have heard of this for a variety of reasons. One of which is that it is a 2,000-year-old device that is incredibly advanced and complex for when it was made. It's often described as either a combination of clock and computer or mechanical calendar. It has a large number of gears, it's labelled, there are many things to it that make it quite impressive for what it is, and all these moving parts interconnect. Remember that we could only really reliably create clocks in the last couple of 100 years, and yet this device uses many of the same principles and methods from 2,000 years ago. Why then would this thing that we found back at the start of the 20th century be back in the news? Well, quite simply, it's been scanned yet again, and this scan has let researchers figure out some of the previously less well understood components, particularly some of the parts that are missing, labeling that wasn't entirely clear looking at the corroded brass that makes up a large portion of it. The device for what it is incredibly advanced, and not only is it advanced, but the materials and ideas available at the time would have been challenging at the least to be able to create what we're seeing here. And there are some YouTube channels that are recreating this device using ancient methods. A link to those can be found in the description below. You can see how they're building the Antikythera mechanism from the available information using period-appropriate techniques and tools. That's all the news we have for you this week. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.